Again, like we just looked at the other two, I have 93%. So obviously 7% is left here and here, so this must be half of that, 3.5%, and this must be 3.5%. So this area is 0.035, and of course this one is the same. So I want to determine this z, and I want to determine this z. So use inv norm. Okay. Can I copy that? Will that work? Okay. Yes. So so this is 3.5. Okay. And that's it. Okay. So we have negative 1.8119. Of course, the other one is 1.8119. But now I have to be careful what they want. Let's see what they want. So rounded to decimal places. I think they want the positive side. 2 decimal places. 1.81. They should have accepted both. They should accept the negative and the positive. It doesn't matter. But they established that what they are looking for is positive. So careful on that. Both should work. Okay, this is the same thing. You know how to do that now, unless you want me to. Let's continue. Any preference?
14.
Good. Okay, somebody else would like to start this?
I can read it again.
Thank you.
Determine the point estimate of the population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample with specified characteristics x for the sample size provided. The lower bound is 0.199, upper bound 0.471, and n equals 1,000.
I copied, and n equals 1,000. So they want the point estimate, which is p hat. They want the margin of error and the number of individuals in the sample with a specified characteristic, which is x. So these three they want, and the given information is here. Okay. So as I mentioned, because I knew that these problems come up, in order to find p hat, I have to add this to this and divide by 2. So p hat will be 0.199 plus 0.471 divided by 2. It has to be right in the middle.
So I got 0.335.
0.335. Very good. So that's our p hat. Because we know that p hat equals x, which we do not have, divided by the sample size, which we do have. In this proportion, I can cross multiply. This is over 1. X equals p hat times n. So x p hat times n. I determine p hat, and I have n. So the number of people in the study, 0.335 multiplied by 1,000. Easy to do. So x equals 335. So we have this. Now we need to determine the margin of error. Very simple, because we already discussed that. If this is right in the middle, 0.335, I have two ways of determining the margin of error. 0.335 minus this number, or 0.471 minus 0.335. The answer has to be the same. So the margin of error is this minus this. 0.335 minus 0.199.
Which is 0.136.
136?
Yep.
Very good. So now we are entering the answers. So the point estimate of the population proportion is, we got 0.335. The next step, they're asking us to find the margin of error. We did 0.136. In the next step, we want the number of individuals. Yes, we determined that, 335. Oops. And finally, they're asking what? Nothing. Okay. Okay, what about this one? Other than Emily.
I'll read it.
Thank you. Thank you, Mani.
You're welcome. The results of a survey on the belief that stem cell research has merit are shown in the table below. X 1,520, N 2,100. Sample P is 0.73810.
Sample proportion, yes, and the confidence interval, 95% confidence interval, CI. Good. X
That's 0.707.
Yes, we see it. X denotes the number who believed. Okay. Explain how to interpret the sample population. The sample proportion, sorry. And 95% confidence interval in this table. So the sample P, so the sample proportion, is the proportion of those who, in the study, who consider that the stem cell research has merit. Okay? So the proportion of all respondents, this is the sample. We're not there to the proportion, to the population proportion. Okay? This is the sample proportion is the proportion of all respondents in the sample who believe such and such has merit. Okay, so 1520 divided by 2100, which is 0.72 dot dot dot. Before we continue, if you look here carefully, is there any error? What do you think? Before we continue reading and answer the rest of the question. Is there anything that bothers you in this table with 2 rows and 4 columns? Anything that bothers you here? Anyone?
No, I don't think so.
So this is it's the results of a survey, right? They're not saying that this is a census. They didn't go to everybody. So it's a survey, right? So it's a sample. So anything in this information bothers you? Because there is one thing that bothers me very badly. Anyone? Well, this bothers me completely.
The uppercase there?
What letter do we use for the sample size?
Isn't it just lowercase?
Right. What letter do we use for the population size?
Capital.
Right.
Capital.
So this is an error. We know that clearly that this cannot be 2100, the population size, because it says a survey. Right? So be very careful. We found a lot of errors here in this book. For some reason, I don't know why. They're not paying attention. That's a very important detail. Okay. So, and the 95% confidence interval is the 95% confidence interval, and it means that we can be how much confident? What goes in here?
95.
Of course, that the interval, I copy the interval, 0.7047 and 0.7429 contains what?
Sample? Is this sample?
The true population proportion, right? We wrote it a few minutes ago. The true population proportion. So round to 4 decimal places, so they just told me to copy, right? So one more time, the sample proportion is the proportion of all respondents in the sample who believe such and such. Now, the confidence interval, which is this, the 95% confidence interval is the 95% confidence interval and it means that we can be 95% confident that this interval contains the true population proportion. So we not only estimated the true population proportion with a point estimate, but also we estimated it with an interval. What is 95% margin of error associated with the poll? So we know how to do this, right? So from the sample, p hat, this is notation is p hat minus 0.7047, and that is the margin of error, or the upper limit of the interval minus the sample proportion, one or the other. Round to 4 decimal places. So what do we get when we subtract? I'm looking.
0.0191.
0.0191. Okay. Perfect. Is there another part? No. Okay. Anything else? Or we move on to I have to stop sharing for a second. Okay. So we know that the margin of error is, remember, it's coming from p hat minus the margin of error, p hat plus the margin of error, and this is the confidence interval. So the margin of error for proportions, as we know, is z, that's z alpha over 2, and the square root of p hat 1 minus p hat divided by n. What if I'm given the margin of error? Let's say the margin of error is 0.03. Find n. How big of a sample size should I choose for a guaranteed margin of error, or chosen, maybe not guaranteed, but chosen margin of error 0.03? And let's say I'm told that the confidence interval is, let's say, 95%. How do I do this? How do I determine n? And let's say from a previous study, or we have p hat. Give me a p hat. Any p hat you want. So we can determine the sample size. Anyone wants to give us a p hat? Is anyone else here other than Emily, Emma?
Can we do 22?
Okay, so I'm going to say that this is 0.23. By 22, you meant 0.22?
Yes.
Oh, okay. I thought you were looking at the problem 22.
No.
0.22 is perfect. Excellent. Great job. So I want 0.03. I know that z for 195 for 95% is 1.96. We calculated a few minutes ago. For 95%, 1.95. 1.96, of course. The square root, I have 0.22. 1 minus 0.22, close the parenthesis, divided by n. How do I solve this equation for n? First, I'm going to divide both sides by 1.96, 0.03 over 1.96. And then I have the square root of 0.22, and 1 minus 0.22 is 0.78 divided by n. And then I'm going to square both sides. And I get 0.03 over 1.96, and that's everything squared. And I get here 0.22 times 0.78 divided by n. And now I cross multiply this number times n, 0.03 over 1.96 squared times n equals this number. Now I divide by this number. You don't have to do all these steps. You can just use the formula, but I wanted to show you how we get the formula. Over 0.03 over 1.96 and everything squared. Yes, you can flip this. That's much easier. So I have 1.96 over 0.03 squared times 0.22 and times 0.78. And I'm going to share and use the graphing calculator to do this. And that's how we determine the sample size. So 1.96, no, I didn't mean that. 1.96 divided by 0.03 and square, and then multiply by 0.22 and multiply by 0.78 and press enter. We always, even if this number, the first digit, the 10th digit is 4, we have to round it up. It's mandatory. 733. So the sample size I have to collect if I'm interested in finding a 95% confidence interval, and if I want the margin of error not to exceed this 0.03, and knowing the proportion. And you can say you didn't even collect the sample. How do you have the proportion? From an earlier study. Because I don't have the data. I don't know what the sample size should be. But that was from an earlier study. And you can say, but what if we don't have an earlier study? Then we will consider 0.5 as the first estimate, and we go back and do it again. So I have to collect 733 observations, and in order to get a margin of error of 0.03 at 95% confidence. Using this. Using this, I'm going to get a different number. If there is no prior study, I have to use 0.5. If there is a prior study, I will use the prior study to come up with a sample size. So